All right, we're in my lab here. We're doing Cisco networking subnetting, and I've got a sample question on the board that will help you. It's one of the harder questions you're going to see in a subnetting type question. That it's kind of difficult unless you really know how to find the subnets. You know how to find your networks based on your subnet mask. And I like to use a system called Magic Number, and I'm going to show it to you right now and show you how you can answer a question like this. Let's look at this sample question. Okay, we've got a host with an IP address, and then a router. Here's his gateway, this host's gateway right here, and then there's an IP address here. Okay, so they're on the same network. Here's the computer, here's the client or the host, and then here's the gateway right there. There's the IP address. And then over here we've got another router with an IP address over here, right? And here's the gateway, and here's the host on this network. So we've got a picture of two networks here, over here and over here. Client, gateway, client, gateway. Okay. Then you have to, according to this addressing scheme, which subnet mask, as an administrator, would you need to use for this to work? For this to work. Okay. And to do this, you have to understand the subnet mask and what networks are made by what subnet mask. Okay, so in this case, we have to figure out what are the networks to see if this scenario would work. All right. So the first one we're going to examine is a /25. All right. A /25 subnet mask is the same as a 255.255.128. Well, how do I know that? I know that because this is 8 ones, 1, 2, 3, 4, 5, 6, 7, 8, and 8 ones, and 8 ones. Right, there's 24 ones, and then a 25th one, and then 7 zeros. Right? And in this scenario, the networks that are created with this subnet mask are two networks. If it's subnetted with a /25, we end up with two networks. 0 to 127 in the last octet would be our hosts. Our network number would be 0, our broadcast number would be 127, and the hosts in between. And the 128 network to 255, with the 128 being the network number, and the subnet mask, the broadcast address being 255, with hosts in between. How do we know this? We know this because of the magic number. The magic number in this case is a 1 in the 128th place. In other words, with these 8 bits, we have place values in binary, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, so on and so forth, making place values (128's place, 64's place, 32's place, 16's place, 8's, 4, 2, 1), and we have a situation where we have 1, 0, 0, 0, 0, 0, 0, 0, right? And the 1 is in the 128's place. Okay? So, in this scenario, /25 creates two networks, 0 to 127 and 128 to 255, and that would not work with this addressing scheme. Why? Because 49 and 62 and 33 and 47, they're all in one network. And we need two networks to function for this network, for this diagram to function. So /25 does not work, right? Let's check out the /26. A /26 is 26 ones, right? That's 24 ones, 25, 26, and then 6 zeros, right? And we have to find the magic number. The magic number is in the last octet. It's the last one, the last borrowed bits. We call these the 2 borrowed bits, right? Otherwise it would have been a normal 24-bit subnet mask, but it's not normal. It's /26 would be 255, 255, 255.192. That is not a classful subnet mask, right? The 192 is not normal. It should have been 0, but it's been changed to 192, hence it's been subnetted. So the question is, the last borrowed bit, what's the place value? What is the place value in the binary number scheme? The binary number scheme, this is the 128's place, and this one is the 64's place. The 128's place, the 64's place, so the 1 is in the 64's place, so the networks go up by 64. The first network being 0, the second network being 64, the third network being 128, and the fourth network being 192. Okay? 0 to 63, network number 0, broadcast number 63. 64 to 127, network number 64, broadcast 127. 128 to 191, and 192 to 255. In this scenario, we have 4 networks, 4 subnets that are created, right? 4 subnets. But the first subnet is 0 to 63, and we've got a 33, a 47, a 49, and a 62, all in the 0 to 63 network. So that wouldn't work, because they're all in what? One network. So that wouldn't work. So then we go to the next choice, which is a /28, which happens to be the right answer. Okay? Why? With a /28, you've got 8 bits, 255, 8 bits, 255, 8 bits, 255, 8 bits, and then in the last octet, right, you've got a 240 in binary, that is 1, 2, 3, 4 ones and 4 zeros. All right? The magic number, the last one, is in the 16's place. 128, 64, 32, 16. The magic number is what?
16.
Magic number is what? 16. So the networks go up by?
16.
So the networks go 0 to 15, 16, 32, 48, right? 64. And you can see here that we've got 49 in this router and 62 for the host. 48 to 63. 48 is the network. 63 is the broadcast. 62 is the last usable host. 49 is the first usable host in this subnet. That works. Over here, we've got 33 and 47, right? 33 and 47. Well, I made a mistake because it goes 32 to 47, right? So this needs to be a 46 to make it work. My bad. Can I change that to a 46? You bet. Okay, so in this scenario now, we have 33 to 46, and 33 is the first usable host in between 32 and 47. The last usable host is 46. If it was 47 here, that would be incorrect. And we have 2 separate networks, 32 to 47 and 48 to 63. And we have the right answer. Okay? We have the right answer. Now, because first usable host, last usable host, it's good. Now, if we were to go to size 29, the networks would be size 8, and these addresses are more than 8 numbers apart. So that wouldn't work. 46 minus 33 is more than 8 numbers apart, and that would not work. All right, that's it.